Hi, welcome back. Even we're still in chapter reaction kinetics, but today we're going to focus on 8.3 factors affecting the reaction rate. In this subtopic, we have 6 learning objectives. However, learning objective A is actually recalled from the SPM content. So B and C is explanation, while learning objective D, E, and F is more to calculation. Now let's start with the learning objective A, the factors that were influencing the reaction rate. First, concentration. Basically, concentration is only the keyword that we remember. The correct way we want to answer, we supposedly mention concentration of reactants. The second factor is pressure, so same case as well, pressure of reactants, and then normally these reactants are in the phase of gas. While for the concentration of reactant, the physical state for the reactant always is in aqueous. The third factors that we are going to discuss is particle size of reactant as well, but this one will focus on the solid. The fourth factor is the temperature. However, when we want to mention about temperature, we have to mention about temperature of reaction. Okay, we have to give the complete answer. And then the fifth factor is catalyst. So we have to mention the terms aiding catalyst or the presence of catalyst. Okay, we cannot just mention catalyst. So, but the keywords that I type here, concentration, pressure, particle size, temperature, and catalyst are only the keyword that you remember. When you're answering the question, you supposedly mention completely. Now let's proceed to the explanation. How the factor of increasing concentration increase the rate of reaction. Again, reminder, normally increase the concentration of reactant always is referred to reactant which are in aqueous solution form. So for example, if one container, at first we have only 2 mole of the molecule in 1 liter, so this one the concentration is 2 molar. While if we have another container, the concentration the volume is still 1 liter, but this moment now we have 5 mole of molecule. 5 mole of reactant are inside, so the concentration will become 5 molar. So when we look at this diagram, we will notice that in the same container, when we increase the concentration, the particles present per unit volume is increased. So that's why here they use the word more particles present. So when this happens, you can compare this diagram in 2 molar and 5 molar here. At 5 molar container, the frequency of the collision is increasing. At the same time, the chances to have effective collision also will be increased, and hence it will cause the rate of reaction increase. So basically, this 3 main point is always general, which you need to mention for every factor. However, you cannot miss out any frequency of collision or effective collision. Both these two must be present. All these 3 must be present, then only you will have around 1 mark for this explanation. Okay, now we proceed to second factor, which is increase the pressure. So when we increase the pressure at the same time, actually we understand that the volume of the container is going to increase. So going to decrease. So for example, this is the container. We have the gas. Then now because of you increase the pressure, so the volume is decreasing. So again, when we compare the container A and container B, you will notice that in container B, due to the volume is decreasing, the particles present per unit volume also increase. This will cause the frequency of collision increase, followed by effective collision increase, and finally the rate of reaction also will be increased. The third factor is the particle size, which normally involve reactant which is in solid form. So when the smaller particle size means that the exposed area is greater. So again, when the exposed area is greater, the chances for frequency, the chances for collision is increased, and effective collision will be increased, and finally the rate of reaction will increase as well. The fourth factor is increasing the temperature of reaction. When the temperature is increased, more particles will move at higher speed. So when most particle is at higher speed, that means the chances for the molecules to achieve activation energy is greater. And then frequency of collision again will be increased, and the chances of effective collision also will be increased, and then this will cause rate of reaction increase. Why we have to mention about the activation energy over here? Because the definition that we learned in 8.2 mentioned that activation energy is energy required to initiate a chemical equation. Okay, not the gases. Any reactant molecule always will be moving, but even though they're moving, they collide each other, they will not necessarily will become the product, because we know to fulfill the requirement for the effective collision, two requirements: collision with correct orientation, and the molecule must have the energy equal or greater than the activation energy. So because of the temperature, we relate with the energy. So here we have to mention about the activation energy. The last factor that we're going to explain here is presence of the catalyst. So the keyword over here is mentioned that the catalyst will provide an alternative, okay, pathway with lower activation energy. Alternative, that means pilihan yang lain. Okay. So and then, or we can say that the catalyst will provide a shortcut. Okay. So this shortcut pathway will only use lesser activation energy. So when we transform this into the diagram, energy profile diagram, you will notice that this higher peak one is the one without catalyst. So the other one which have the catalyst, it will provide alternative. So this red dotted line is the alternative. Why we say that it is alternative? Because the pathway is different from the red line here. So the red dotted line is another pathway, and then this pathway need lower activation energy. So then more molecule will have sufficient energy to collide. Again, frequency collision increase, effective collision increase, and finally will cause the rate of reaction increase. Let's continue with tutorial question number B. If you still remember, basically we already sketched and leveled the potential energy diagram for P1 and P2. However, we haven't done this part yet. Okay, so indicate the change on the diagram if platinum is added. So in this case, we will treat platinum as catalyst. So as we know, when the catalyst is added, the activation and the pathway that the reactant go through will be with lower activation energy. Okay, so that's why when we want to do the comparison to see the changes, we have to compare using the same energy profile diagram. So previously we already draw this curve, activation without platinum. Then now we are having the another one because we already added the platinum. So we have to draw another pathway which showing that this is the alternative pathway with lower activation energy. Okay, so you can label it as activation energy with platinum, or you can substitute the platinum to catalyst, also no problem. But basically, if the question let us know the exact catalyst, then it will be better we always follow the question. Okay, next, same case for the second one, the chlorine molecule to chlorine atom. So again, you will notice that the one without platinum have greater activation energy, while the one with the catalyst platinum will have lower activation energy. Again, you will notice that the line that you're going to draw here, okay, the black line and the red line, you need to show the difference, okay, because the pathway we already mentioned based on the explanation is alternative. Alternative means that another method, okay. So we notice that sometimes some of the students, they draw like this, okay, they exactly same at the beginning. Here the pathway are similar, okay, they just trace on it and then only they go down. So if you label with this, the red line here is considered wrong because this one doesn't show like alternative. Tutorial question 11. Question A we already done in previous video, so now we focus on question B. In this question B, you are given one chemical equation at where reactant and product with the physical state of gas, and also red law also given. When the red law is given, from here we know that this one is second order. Okay. Next, let's continue with the question. With respect to above reaction, explain how the reaction rate will change if the pressure of NO2 is double. Okay. So basically, we already know if the concentration increase, the rate of reaction also will be increased. But because of in this question, they show us the red law, so we know if the concentration is double, so the rate of reaction also will rise to the power of 2. So that's why when we mention when the pressure of reactant increase, so in this case, actually you can replace the terms reactant to NO2, which is more fulfill the requirement of the question, because when you mention when the pressure of reactant increase, this is too general. We should be more specific based on the question. So you can replace the term reactant with NO2 increase. The number of reactants molecule again, you also can replace with NO2 per volume will increase. Then NO2 are closer to each other and increase the number of collisions. So again, you can see we will mention about the molecules per unit volume increase, and then frequency of collision increase, effective collision, and then only we will mention the rate of reaction also increase. In this question, we have to emphasize increase by how many factors. Why we have to do this? Because the red law is given in this question. So that's why we have to more specific according to the question. Let's say the question doesn't give us the red law, so we no need to mention increase by the factor of 4 is okay. Now, next, the second part is about the temperature. So basically, you will notice that this explanation is quite similar with what we discussed in previous slide. When the temperature is increased, the average kinetic reacting particles, again, you can change this to NO2, also increase. Okay. Then more molecule will possess energy equal or greater than activation energy. Then the number of collision and also the effective collision will increase and cause the rate of reaction increase. This objective question also from tutorial. So we look at number 3 here. For the reaction A react with Y will produce AY with the rate equation is found to be rate equal to K concentration A to the power of 1 and concentration, I think this here it has the typo. So should be concentration of Y to the power of 0. Which of the following set condition will give the highest rate of reaction? So we know that we are going to discuss based on these two factors, concentration and also temperature. As we know, concentration increase, the rate of reaction also increase. Same case happen to the temperature. The higher the temperature, the higher the rate of reaction. So now, because in this question the rate law is given, so we cannot we need to refer to the rate law to check the concentration, how the concentration can affect the rate of reaction. So for the concentration of Y, again this one supposedly is concentration of Y, it is 0 order. So no matter how you increase the rate of increase the concentration of reactant, the rate of reaction will not be affected because any number rise to the power of 0 always equal to 1. So that's means in this case we are going to ignore the factor of concentration Y. Then now we look at concentration A, we have 0.1 and 0.2 concentration. So basically again we know that concentration A and D maybe will be, concentration A, option A confirm will be out because it has the lowest concentration and also lowest temperature. Okay, next, then we will check the temperature. So this one even is 0.1, it has the highest temperature. Okay, but then here we notice that this one is 0.2, but the temperature is 40. So that means we can compare B and C. We will choose same concentration, but the temperature is different. So in this case, option B also will be out. So now left option C and D. So for both option C and D, they have same temperature, which is 850 degrees Celsius. That means that we are going to check the concentration. So in this case, option C will be the answer. Okay, this slide we're going to show you a few questions about the factor that affecting the rate of reaction during the UPS. So for example, in the UPS 2005 and 2006, they asked us to explain the effect of temperature on the rate of reaction. While 2006 and 2007, they asked us about the pressure. And 2007 to 2008, they asked us about the catalyst. So generally, these three questions is very general, which is a bit different from what we discussed based on the tutorial question just now. Okay, that's one they have give us the red law, and also then we will consider, then we have to explain further. Okay, if it is explained generally, again, no matter what are the factors, so I think you can refer back to the table, the summary table that we discussed previously in the previous slide. So you have to keep in mind that when you explain this, you have to relate to the collision theory, and then have the keyword frequency of collision, effective collision, and then you relate with the rate of reaction. Now let's continue with the learning objective 8.3c, which is related with the Maxwell Boltzmann distribution. So this Maxwell Boltzmann distribution will be related with the temperature, the factor of temperature. So now let's look at the first graph that's showing here. Okay, the y-axis here mentioned is fraction of molecule having a certain kinetic energy. So we can simplify this one as the number of molecules. So the the x-axis here is represent the kinetic energy. So this line here is represent the activation energy. So that means in one container there are quite many of the molecules. Okay, for example, maybe at this moment, okay, there is very little molecule with lower kinetic energy. Majority of the molecule are majority because the peak here is the higher, so that's mean majority of the molecule is moving at this kinetic energy, which is less than activation energy. So all the molecule moving at this area here, they are not able to initiate the chemical reaction, because as we already know, the one of the criteria or requirement for a reactor to initiate the chemical reaction is they must possess the energy equal or greater than activation energy. So the shaded area here is represent the molecule with kinetic energy equal or greater than activation energy. So that means the molecules under this value have the tendency to undergo chemical reaction. But again, don't forget, this one they only fulfill the first requirement. There is another requirement, which is the molecule must collide with the correct orientation. However, in this Maxwell Boltzmann distribution, we only focus on the temperature, the factor of temperature. So means that we only focus on the to the activation energy. So now I show you another graph. Okay, so this graph also basically the y-axis is still represent the number of molecules, and then the x-axis still represent the kinetic energy. So again, the shaded area here still represent the molecule with the kinetic energy equal or greater than the activation energy. So because of just now we say that the Maxwell Boltzmann distribution is related to the temperature. So that means now I would like to share with you the idea that T1 and T2, which one is happen in the higher temperature. Okay, so now we try to look at the first one here. At higher temperature, more molecules will move faster. Okay, this is the statement that we already learned in the previous slide. And then you agree that when they move faster, the kinetic energy will be increasing. So when we look at here, we have graph T1 and T2. Sorry, maybe I use back the term that I mentioned here. T1, T2, okay, the graph T1 and T2. So based on the first statement over here that at higher temperature, more molecule move faster. So when the molecule move faster, means that they will have higher kinetic energy. So when we compare this graph T1 and T2, you will notice that basically T2 is the temperature is at higher temperature. Why we say like this? Because when you compare the peak here, for example, at this higher, even though the number of molecules is lesser, but you will notice that majority of the molecules, they are moving at greater kinetic energy, okay, with the higher kinetic energy. Okay, so now we look at the second second statement of the explanation. At the same time means that at higher temperature, the number of molecules with kinetic energy will be greater than the activation energy, also more compared to lower energy. So when we look at the area here, this area is larger. Okay, the shaded area is larger, means that more molecule possess the energy equal or greater than EA. So again, when we apply these two statements based on the graph showing at the left hand side, we know that T2 actually is represent the reaction carried out at the higher temperature. Okay, so finally when we relate to the explanation, therefore the frequency of effective collision at higher temperature is greater than at low temperature, and hence they will increase the rate of reaction. However, to keep in mind that if the question asks you to sketch the Maxwell Boltzmann distribution curve, the graph that I showed you in the previous slide is not correct because that one I'm using separate it into two graphs, okay, two curves, okay. But if mentioned Maxwell Boltzmann distribution, basically we are combining the two curves in one in the same graph. So this supposedly is the graph that required you to draw, and where we combining the curve at low temperature and high temperature, and then only we do the explanation. So again, when we overlap these two curves, we will notice that the overlapping area at higher temperature is more compared to the lower temperature. Okay, so and then sometimes you also will notice that this one is using the color. So basically, actually here, supposedly will become more purple color because we have pink and blue color overlap, it will become purple color. So if we didn't sketch using the color, then maybe we because normally in exam we are not bringing the color pen with us, so we are going to use the pencil. So when you use the pencil, this curve basically will be you can be draw like this, okay, which is represent the line that to the left hand side is represent the total molecule at T2, while the one which to the right side is represent the lower temperature. Okay, so this one T2 again is higher temperature, while the bottom here is lower temperature. So to keep in mind that when you want to sketch the Maxwell Boltzmann distribution, because you are combining two curves in one graph, okay, so you have to make sure the shape, okay, basically both have the same shape, only the peak, okay, the peak for the higher temperature, they will have lower peak. Okay, and then the axis as usual must be labeled. Y-axis is the number of molecules and the x-axis is the kinetic energy. Maybe you can include the unit kilojoule per mole. And then don't forget you need to represent the tail, and then you have to draw out one line. If you notice that there is one line to show that this line actually is represent the activation energy. So the area that at the right hand side of this line will be considered possess the energy greater than the activation energy. Now let's continue with the tutorial question number 12, which is related with the Maxwell Boltzmann distribution. So when you look at the question here, explain the effect of temperature on the rate of reaction based on the Maxwell Boltzmann distribution curve. Quite similar question also come out during the UPS 2009 and 10. Based on the Maxwell Boltzmann distribution curve, explain how an increase in the temperature would increase the rate of reaction. Okay, so now we directly to the question here. Like just now we mentioned, we have to label the axis, okay, and then the curve, the shape is correct, and then the peak for the higher temperature. So you see the T2 is higher temperature, have lower peak. Okay, and then the tail, the area at the tail here also is the bigger. So the graph, no problem already, have no problem. So then we need to do the some explanation. The above diagram shows Maxwell Boltzmann distribution for a gas at T1 and T2. This is why just now I did mention that if you want to sketch the graph, sketch the Maxwell Boltzmann distribution, you basically is combine two curves at different temperature at one graph. Okay, so then you have to label T1 and T2, which one has the higher temperature, like this. The shaded area represents the number of molecules poses energy equal or greater than the activation energy. Then now we refer here, the higher the temperature, the more molecule will have average kinetic energy equal or greater than activation energy. So this part actually is represent the shaded area. Okay, when we look at here, T2, the shaded area for T2 is larger, so that means it will be represent more molecules. Okay, therefore more molecule can achieve the minimum energy for reaction to occur. Thus the rate of reaction will be increased. So before we continue with this, then will be better that you again include the one that we mentioned before, mentioned about the frequency of collision. Then only you mention about the frequency of effective collision, and then lastly you relate with the rate of reaction. So I think for this video we will stop at here. So the learning objective of 8.3 D, E, and F, which related with the Arrhenius equation, will be shared with you in the next video. Thank you.